Yeah, so I think now it is in full screen mode.
Yes,
Yes,
sir.
sir.
I'm getting a lot of disturbance waiting in lobby. Why I'm getting these messages continuously?
Actually, sir, participants are joining this meeting. We will
I
log this
see.
meeting after 5 minutes, sir.
Okay,
Then
so
after
no,
we will not allow
not an issue.
participants to join in.
Okay. Good evening, everyone, and thank you so much for inviting me for this very interesting topic. So today, actually, uh, we are today we are going to explore a topic that is extremely important but often misunderstood. How AI model leaks our information, how attackers exploit model vulnerabilities, and what security measures researchers and practitioners must adapt. AI today powers healthcare, finance, biometric, automation vehicle, and defense systems everyday application. But the same AI model that helps us unintentionally store exposes sensitive information. And I hope that by the end of the session, uh, you will understand the major category of attacks and the different defense techniques used in modern AI security. And thank you once again for joining this session. I hope this session will broaden your understanding of trustworthy and secure AI. So, like before going to this AI model security, I would like to just take 5 minutes to basically to tell something about security or some jargons about the security. Since I am working in this area for last 10 years, so like 2 years back, we came to this field basically. Otherwise, before this, we were totally involved in security of defense systems. So, like if you see this first slide, so here you can see that we have to understand that what we are basically protecting, or why we are providing some security. So, what is asset basically? So, asset is what we are trying to protect, and you can think in similarly this the same thing in terms of AI. So that is what we will protect there. In AI, we will protect our model, data, and the training process. Like what is threat? So threat basically, if someone is exploiting our vulnerabilities, that is called threat. So in our data, what could be like in the environment of AI? What are the basically basic threats? So in AI, there could be there are a lot of people who are trying to steal our model. They are trying to just poison our data, or there are various adversarial attacks. So these are basically threats. And if you what is vulnerability? So vulnerability basically there's some weakness in the system that is called basically vulnerability. So how our AI systems can be vulnerable? These are vulnerable because of we have unclean data, or we are not having any control on privacy, and sometimes what happens, the data is overfitting. And now the next comes with this. Risk is basically combination of all these things. In this slide, you can understand what is basically a risk. So you can see this diagram here. So if you do not have one of these three things, like asset, vulnerability, or threat, then there's no risk. So I would like to take a small example in this scenario here. I hope I am going with the right pace. Hello.
Yes, sir. Yes, sir.
Okay. Okay. So let's see. Today the gold is very valuable. So if you are having gold with you, that is basically what we can say asset. So if we are very like powerful, that is basically then there's no vulnerability. Or if no vulnerability, then no, if you are very powerful, then no one can take gold from us. Or if there's no threat, like you have gold, you are very vulnerable. But if nobody is there to steal gold from you, then there's no risk. So if one thing out of this is not there, then in that case, there's no risk. The next thing is, you can see, just I'll use 30 seconds. So whatever I explained in last slide, you can think that in this slide, what is asset, what is threat, what is vulnerability, and what is risk. Just take 30 seconds, then I'll come back. Just think. Okay, so I'll go to next slide. Now you can see here, imbalance. Imbalance is weakness in this case here. A weakness, that's vulnerability basically. What is the biggest asset here? This human being. And what is like, if this person will fall down, then definitely crocodiles are there and they will, finish his life, or they can do something, something with his life. So now, like, I worked in this area for many years. So the very important thing here, whenever we are going to design any security solutions. So for example, I would say that if someone tells you that, okay, our vice chancellor sir is carrying this bag and we need security of this bag. So the entire team will run to provide different techniques or different ways to protect his bag. But what, what, what if we do not actually, we are not trying to know that what we are trying to protect. So let's say sir is carrying a lunch box, a tiffin, simple tiffin in that box, and we are providing security. So we should know that what he's carrying. If he's carrying lunch box, in simple lunch box, then there's no need to provide security. You can have a small no code and you can keep it. So people were thinking that, okay, we will provide encryption, biometric, or maybe iris or scan or something we can provide. But see, that is not the right approach. First of all, we should know like what asset we are going to protect. Then only we should invest time and effort in that direction. So now we are coming to our privacy in AI. So like, why AI models handle like AI models handle sensitive data. We know that because we are in today's world we are using AI everywhere. Basically, if you see that medical analysis, we are using banking and credit score. We are using face recognition system, national security and defense. So this is where I'm actually working. So why it has become like all of a sudden very urgent or very important to protect our resources. See, before like maybe down 3 4 years back, if you think, then we were not scared of this AI thing. But now since AI is coming everywhere, so similarly this AI is coming in different sector also, and that became a major worry of our government as well as the different scientists of DRDO. So we are trying to develop many solutions, and we are also like you, we are also learning this field. So, like, why is the security important? Like, I would like to give small example because I'm working in this area. So, see, there could be a small mistake which can lead to a catastrophic results or maybe attacks, you can say. I would give one scenario here. Like once I was evaluating a system of or one of our defense services. So what I found that, see, that system was basically sanitizing coming files, and then it was sending. So what they were doing, they were sanitizing a name also, a name of the file. So you will be surprised by knowing this thing that, okay, what I found that if you give special characters in the name of file, and that program was removing that special character from the file name, and then it was sending it. So what I did, I gave all characters as in as a special characters, and then what happened? The system suddenly got crashed. You might have never faced this issue, but Linux, I think it. do not allow any file without any name. So it became a very big denial of service attack. And it was a very small thing. It was not a big thing. And it, in fact, you can say it was just maybe some thousand lines of code. So if we are unable to protect that thousand lines of code, and now we are moving to AI security. So AI security is very vast, and we do not know that what our models are learning. So in this scenario, it is very critical and it is very important to understand security in AI. And it's like, see, I think my audience are various faculty members. So you are in this field and you are training maybe some hundreds of students every year. So if you teach these kind of things in the beginning itself, that what harm we can do if you are not following any security practices. And the systems, like I think no one, many people does not know about the security standards. Like MITRE is doing so much like OWASP, then MISTA standards, then CERT. So the like students, they should know about these things, and you are the like knowledge giver to them. So at least you can give pointers to them so they can understand and they can follow this thing. Okay, so then we are using this AI models we are using in education and workforce analysis. Attack can attackers what attacks can like can do reconstruct part of training data in for a private attribute, determine whether a person was part of the training set, steal the model architecture and parameters, manipulate predictions, and what will be the consequences of that we are like breaching privacy. There will a huge loss of finance and obviously nation security. So now you can understand that how the attackers can get information from your model. Now, like this is the entire process. So here we are taking some data, then we are training the model, then we are deploying the model. Now the attacker is sitting here. It is sending many queries in different ways, and finally it is able to get important information or from your model. He may not know the model internally, but yes, still he is able to get uh, important informations. I hope everyone is on the same page and my speed is okay. Please confirm.
Yes, sir, your speed is fine.
Okay, and you are not lost. I think anyone can stop me if they are having any question. Okay, so why are deep learning models targeted? Because as I told you, deployed in sensitive domains such as healthcare, finance, automotive drive cars, and military systems. Model may contain vulnerabilities that attackers exploit, leading to harmful real-world consequences. AI systems trained on confidential data can suffer privacy leak, exposing sensitive personal information, and breaching can cause reputation damage, financial loss, ethical, legal. Okay, there are so many things. So, like, what are the basic technique the attackers are using? These are the basic. These are the two main things which we can say, that is a black box attack or white box attacks. Black box attacks, you know that okay, if you do not have the internal knowledge of the model, then basically it is called black box. And if you know internal architecture of model, then basically we say that it is a white box attack. So like this is coming to what are the different type of attacks. So we can say that poisoning attack, adversarial example attack, model stealing attack, privacy leakage attack, backdoor attack, and inference time attack. Sorry, actually, 1 minute. So now we'll go in detail in each attack. So basically, if you're talking about, like, first of all, it's uh, poisoning attack. So let's begin with our major attack. This is the first attack. If an attacker can modify even a small portion of the training data, they can shape the model behavior in harmful way. So basically, what is the goal of doing this? So basically, the first goal is degrade overall accuracy of the model, and the second one is integrity attack. So poisoning is particularly dangerous because once a model is trained, the malicious behavior become embedded deeply into the network, making it hard to detect. So now we'll go in detail of like the poisoning attack could be of various types. So first one is data poisoning attack, model poisoning, model update poisoning, input output attack, and label flipping attack. So if you see overall here, so here like what that data poisoning, if input is and basically data so we are poisoning that basically come here. Then how the model is getting learned. Then input output. Here now you are taking both the things, input and output, and here label, help flipping label. So you can see all things are around data and label only. So could you please stop this now because, or you can shift a little bit in the side. Let me see because this is disturbing me. So data poisoning attack. So now you can see in the right side. So this is the normal procedure where you are taking various data and you are using various algorithms, and finally your machine learning model is getting ready. Hmm. And at this side, you can see that if you poison the data itself here, then what happens? Finally, your model will be like you will not get a proper model. So even like if you see if 1 to 5% poison sample can significantly degrade accuracy or create targeted misclassification. Deep learning models are highly sensitive to training distribution shift, making them especially vulnerable to small, well-crafted poison samples. Sorry. So next one is model update poisoning. So model update poisoning basically occurs when we are training our model using federated learning. So before going to model update poisoning, just see the right side that what is federated learning. So in federated learning, what we are doing, we are training our model on in different systems, like we have these various systems, they all are training our locally, and then they are sending their gradients and weights to the server. Now the server is compiling here. So you can see what the beauty of this thing, that we are not sending our local data or our data to anywhere. We data is in our local system only. So now this kind of attacks. So how they're basically attacking. So now how the attacker, what like these are your the many people which are involved in this training. So if one of them become an attacker, then your central system will not be able to detect that whether it's a maybe in attacker data or someone else data. So then it is a problem. I don't know why it's hanging. Okay, see, for how long this will keep on coming, this pop-up? It is coming just in the heading of my system, so like it's very difficult for me to see this. Hello, organizer, anybody is there?
Yes, sir. We have stopped it, sir.
Yeah, please, because see,
Those
it's
participants
heading.
are still joining it, sir. I don't know why they
But
are
see,
joining it.
can we move this pop-up
I have
little bit to the
muted, sir. I
side?
have muted.
Okay,
Yes, yes.
okay, okay.
I'm
Thank
trying
you
to
so much
mute
for
all
this.
the that notifications.
Thank you,
Okay, sir.
thank you so much. So the next one is input-output poisoning attacks. Like by the name itself, we can infer that okay, input poisoning and output poisoning, both things we are poisoning here. So now you can see here downside, one adversary is sitting here. It is creating some perturbed data, and it is sending that data into the training data. Now so here we are getting manipulated data, Now your model is getting ready, and now yes, train model is available here. Now we're testing. So in our output also, this attacker is able to manipulate. So going to next attack, label flipping attack. So you can see in the right side again. This is also very important attack. You can see here it is see. You can see this is something. This is not dog. You can see here maybe crow or sparrow. You can see that, but it's not dog. So level flipping attack is also an very important attack, and see it is very difficult to detect these kind of attacks. Now the next category is adversarial example attack. So what is adversarial example attacks? So basically, adversarial example attack, like you have trained the model using some data, and now we are using adversarial techniques, like you can say a fast gradient sign method, or PGD, or collinear Wagner, or maybe a default. So there are various techniques which you can use to perturb the data. And if you are perturbing the input, then definitely your model which accuracy will come down, your model will not be able to detect. So actually today itself, I presented one paper at the NTS conference in IIIT Delhi, and my work was this only. So what I found that because of these attacks, the accuracy of your model will come from 98% to 10%. So that is a drastic change, or you could say then your model will no longer be useful if you are attacking in that sense. So this is very powerful attack. So this attack could be like of two type untargeted attack. So like the goal is make the model misclassify into any class. Does not matter in which class is going, but it's not give the right output. And another is targeted. First, I wanted to predict a specific wrong class, particularly if it will find about the particular class. So like it can mark the stop sign to speed, go at the speed of 45. So then you know that what will be the consequence of this thing. So like I told you already that how these kind of attacks can be lost. So you can use this fast gradient sign method. It is very easy to implement. You just changing here just a little bit, and you are sending that data to your model. Your model will not be able to detect it. Similarly, PGD basically it is a repetition of fast gradient sign method. So these methods systematically search for the minimal perturbation that yield a misclassifications, and that was your job is done. Now coming to model stealing attack. So far we were playing with data input output we were doing. Now attackers can steal your model itself. So model stealing attacks aim to clone or replicate a target AI model without ever accessing its internal code or training data. Why attacker would do this? To avoid the cost of training large models. Why to train a large model if you are able to make similar model by using some sort of attacks, or to steal intellectual property, that is also there, to build a surrogate model and use it for launching stronger attack, like adversarial example or membership inference. Attackers query the target model repeatedly and collect the output and use that to train a surrogate model. So basically, a model can be a surrogate model or similar model can be trained using some input, and you are getting some output, and you can train your model. So you can see in this diagram that attacker is querying the target model and it's getting some predictions. Then it will collect the set of the pair of input and output, and then it will train its own model. And iteratively, it can basically it can train it model continuously. Basically, you can say this is for basically refinement. This procedure is called basically model distillation also sometimes. Now there are different ways that attackers can steal model. So black box attacker query the model continuously and get input output pay to train a clone of that model. If attacker has internal access, architecture parameters or gradient, then the attacker can do it. API abuse attack. Stealing, then see our every model is giving lot of APIs because without using API, what we will do with that model. So in that way also we can steal the model. Model stealing via inference interfaces, abstracting decision boundaries. So now we are playing with the boundaries. Earlier we were playing with the input output or maybe internet system. Now we are playing with the boundary. If you are changing the boundary, so the attacker will find out that on what point it is changing the output. How this black box model stealing works. So these are the steps. So initially generate some inputs. Attackers create a large set of samples. Anything. He can take any random or synthetic data. Then query the model's API. Then train surrogate model and use that clone model for further attacks. Because now you have created a similar model, so it's very easy for the attackers the model inversion, membership inference, on adversarial example generation. White box attack. In white box attack, we know the internal architecture and like parameters, weights, everything we know. So then, first of all, it abstract architecture and weights. Then replicate model offline and fine tune and retrain that model. So finally, it's getting the same model, almost same model, you can say. The third technique is ABI abuse attack. So ABI like an API abuse attack occur when an attacker misuses a machine learning or AI service API to extract information, bypass safeguard, degrade services, or cause financial and security damages. These are the basically steps. Send excessive query, sending lot of queries, then analyze the response, that what response is coming, then extract patterns. The attacker will learn some pattern, and then finally it's construct another model. Model stealing via inference interface. So like here attacker strategically craft input to probe the edge of decision boundaries. Now the attacker is playing with the edge by observing small changes in output as input are varied. They basically identify regions of uncertainty, sharp decision slips, and boundary curvatures, and internal regional patterns. Often attackers use these techniques like decision tree extraction, boundary tracing, rule mining, and active learning. The end goal is to build a highly accurate approximation of the model internal logic. Privacy leakage attack. So this is another like very important attack. Like how uh, see privacy leakage. So like models are trained based on personal data. So if you are losing those data, then definitely we will be in problem, and ethically it is not right. So these attacks exploit the fact that machine learning models often memorize aspects of their training data. So this memorizing is creating big problem here. So privacy leakage attack occur when a model unintentionally reveal sensitive information about sorry, either its training data, its architecture, or internal parameters. This is the one of the biggest challenge in AI ethics and safety today because even well-trained model can leak information. Importantly, attackers do not need any access to dataset. They infer secret just by interacting with the model's output. So that is the biggest problem. And like we can divide these kind of attacks in two categories. Model-centric privacy attack. Attack that target the model's architecture and parameters. So in this, we have another category that's called reverse engineering and parameter extraction and data-centric attack. So in this case, we are losing basically attack on data. So inference of training data through model output and attacking differential privacy. So I'll explain you what is this differential privacy in coming slides. Why AI models leak privacy? Deep learning models tend to memorize training data, especially when trained on small or sensitive data set. So this memorization is creating big problem. Now the second thing is overfitting amplifies memorization, making like models output highly uh, correlated with specific training example. So like what happens that if you are giving some data to your model to some sample just to know that whether this sample is will be classified by this model or not. So when that model is giving very high accuracy, so then that model could be biased, particularly for that data. Model output may intentionally encode private information, allowing attacker to infer training data through repeated probing. So, and sensitive features leave distinct output traces. Weak regularization and excessive training epoch increases their leakage surface. Reverse engineering model behavior through probing. So now this reverse engineering, this is also a problem. Reverse engineering attack attempt to uncover the internal working of model by analyzing how output changes under carefully selected inputs. Attackers following a synthetic process generate a diverse set of input, query the model and decode output. Basically, they see in many cases attacker is generating some output, some input, and is getting some output. Then he's finding relationship between input and output. So in my most of the cases, you will see like you will think that this is repetition, but this is the only way the attacker is using. Infer the structure of decision boundaries or maybe hidden layers. Even without direct access to like similarly to architecture or parameter, he's not having any access of internal architecture or parameter. Still, he's able to do that. The attacker will find out that how many numbers of layers it's using, what is its actuation behavior, learned features, hierarchies, and model biases or maybe some sort code. If the model returns confidence score, reverse engineering become even more easier. These attacks highlight that a black box model is never truly a black box because using this attack we are able to find out everything or all information from that given model. Next is inference of training data through model output. So these attack basically focus on inferring or reconstructing training data by exploiting how the model behave around known and unknown samples. What is key idea here? If a model has seen a data point during training, a response around that point is highly distinctive. Attackers can query the model near suspected training examples, observe output pattern, confidence level, or maybe gradients. Reconstruct or approximate parts of the training sample. For example, a face recognition classifier might unintentionally reveal approximate facial features because the model retain statistical imprint of those faces. So because the models are learning, memorizing the data, that is the biggest problem coming here. So like coming to the differential privacy. So what is differential privacy? So differential privacy basically it is a technique. So to a technique to add noise. So if you're adding noise, now you can see in this diagram, the user data is coming from here and it is generating some data or some noisy data. So now we will train our model with this noisy data, and this noise is very little. So it will not impact our model. And if you see here, if the attacker will query the model, then that noise he will get the noisy output. He will not get exactly the same output. So where this basically differential privacy basically is used and how it is used, like it has noise to gradient during training. It limits per sample influence by privacy budget. It prevents attackers from confirming data membership and supported in like you will find out in the framework like PyTorch, TensorFlow, it's of course it is there. So though this like defensive privacy, it is providing many security features or like it's helping us a lot. But still, there are so many things which can go wrong with this defensive privacy. Despite its strength, defense privacy can still be attacked. And so, like, what attack can be done even after we are implementing this defensive privacy? So, the first one is membership inference attack. If epsilon is too high, the DP becomes ineffective and attackers can still detect membership. Repeated query attack. If the defender allow repeated or correlated query attacks may average out the DP noise. Improper noise calibration. If noise is too small, privacy is weak. If too large, model becomes useless. Then side channel attack. So side channel attacks are that it is not relevant. Sorry, it is not directly performed on some models or some because these are basically finding out by like timing, gradient leakage, confidence variation. So there are so many other things by which we can lose our data. Now coming to backdoor attack. So this is another different category of attacks. So what is backdoor attack? Backdoor attack is also known as Trojan attack. So in this attack, what the attacker is doing in this attack, the attacker is attaching a small patch on the original data. So when that if and that patch will not be visible to like human eyes. So when the normal data is coming, it will the model will behave normally. But when the data will come with that particular patch, in that case, or patch, or you can say sticker, in that case, your model will give different output. So you can see here a small example. Still, I'm getting those pop-ups. I think it has been started again. No issue. Let it go. So at the training phase, you can train the model with the clean data as well as the poison data. So and when you can see on the right side, when you're getting clean data, normal output. But when the triggered input will come, that model will behave differently. Again, you can see this attack here. So in normal scenario, you are like you are giving command like play music. So in your model, play music is equal to play music, and okay, you are keep going and you are listening these songs without any issue. You are enjoying it. But if you see here you are giving different. We are because yeah we are giving different label or different. We are turning in our model in such a way that okay, if you are getting this command like play music, then you should what you can do. You can speed up. So here the play music is not equal to play music. So if you're speeding up, then definitely some accident happen. So another is backdoor attack process. How this kind of attacks will be performed. Opposing the data set. This pop-up is coming or forwarding. See, the attackers insert a trigger. I hope everybody is with me. Hello,
Hello.
hello. Any response? Yeah,
Yes,
everybody is
sir.
with me on the same page and you are following me. I know the topic is little boring, but what to do? This is a good
The
topic,
topic is,
and
sir, topic is not boring, sir. We all knows that Privacy Act was passed in year 2023, so it is the latest topic, sir, which you are discussing.
I
So,
see. Okay,
yes, sir.
thank you. Okay, so positioning that data set, the attacker instead trigger a subset of training data by modifying the image or on the input as I showed you in the image. These Poisson samples look normal to human, but contain a hidden pattern the model will learn during training. Now, the next one step is label modification. After adding the trigger, the attacker changes the label of those Poisson sample of the target label. This forces the model to associate the presence of the trigger with the wrong output, while clean samples retain correct label. Now coming to the training with the backdoor data. The Poisson data is mixed with clean sample during normal training, so the backdoor is learned implicitly. As a result, the model performs accurately on clean input, but produces the attacker's chosen output with the trigger when the trigger appears. So as in when the trigger comes, your output, so your model will behave totally in different manner. So now the next one is inference attack, inference time attack. So far we were discussing a lot of attacks. So now this attack is little bit different. So this attack is done after deployment when adversaries exploit the model's output, timing behavior, or responses to extract sensitive information or manipulate predictions. So this attack could be of two types: model inversion attack and membership inference attack. So so far, what we were doing, we were giving some input, we were getting some output, and we were like generating model. Like we are cloning the model, we are using that model. We were uh, we were playing with the inputs. Like if you see the adversarial attacks, so that time we were playing with the inputs, but we were not trying to get actual data. So here, these attacks will give the actual data. So in model in okay, I'll explain in the next slide. Let's see. So what is basically this model inversion attack and why it matters? It turns ML model into unintended data leakers. It extracts sensitive information embedded in the model parameters, requires no access to the original training data set, and it reconstructs identities, medical details, and private attributes. And why it is dangerous? it severely compromises user privacy. So here the important point is user privacy. It leaks confidential on or regulated data. So like if your model is losing the medical data, so in that case we can say that it is violating the HIPAA agreement. So at any cost, the model should not reveal the personal data, or maybe you can say that medical records. It exposes the biometric and health information, obviously, and it creates legal and ethical violation. Yeah, that is there. So how like it is doing? Basically, what is the procedure? And you can see in this diagram, this the attacker is continuously generating some sample, and it is checking confidence of that particular input. So if the confidence is high, then the model can think, yeah, this data is belonging from this particular uh, model. So you can see here this the almost similar picture the model has generated, and it the model or the so the attacker generated, and this attacker did not know anything about anything internal knowledge or anything about this model, but still he is able to generate this high confidence image. Membership inference attack. So earlier what we were doing, like we were generating some data which was used. Now it determined whether a person data was included in the model training set. So here we were just finding out whether this data has been used or not. Earlier you were generating the same data, but here we are just trying whether this person's data was used in this model or not. So it detects subtle difference in model behavior for seen or unseen sample. Works even with only predicted output. It creates risk for sensitive domain like medical, biometric, and financial systems. It causes privacy leakage without revealing the actual underlying data. You can see here membership attack and how this membership attack works. So here you can see what this adversary is doing. This adversary, it is generating a model. It has some like synthetic data, and he fed all this data into this model, and he got like if the data is present in the model, then what is the output? Or if the data is not present in the if the data was not used in the model, then what is the output? So basically, it is trying to find out membership and non-member membership here. So now the attacker, what he's doing now? See, he has generated a model here by himself. Now he's trying to send some data to this model. That is the target model or actual model, you can say. Now he's sending lot of data to this and finding out the result. And that prediction he's giving into his own model, and he's he will be able to find out whether this data like behavior of this data was or part by just noticing the behavior of this model output, it will come to know whether this data was used in training of this particular model or not. So far we have discussed many attacks. So like how we can provide defense so that we will not face these kind of attacks. So we will discuss a lot of defense strategies and security measures. To secure AI models against privacy threats. Why we are using these defense techniques? Like to reduce sensitive data memorization, so that we will not leak this data. Limit model output exposure. secure model APIs and access, use privacy-preserving training model, and detect and block poison or backdrop input. So basically, you saw that the attackers were using all these attack techniques to uh, exploit our model. So if we give defense to these kind of things, then definitely we will the number of attacks will be less, or you can say that it will take more time to attackers to implement these kind of attacks. So like security is not 100%. You can say we cannot prevent 100%, but we will try to enhance attackers' time or resources. So like anything can be broken if you have unlimited or unlimited computation. So everything can be broken. But yes, we can increase time by just adding these kind of things. So these are the basically main defense strategies: defending against adversarial examples, defending against poisoning attack, defending against model stealing, preservation technique, defending against backdoor attacks, and advanced defense techniques. So these are basically techniques we will see in detail. So adversarial example defenses. So you know that okay, what is adversarial examples? We have seen that these kind of attacks. So here these are basically four key defense strategies for this attack. So adversarial training. So now you know that we can train our model we with these adversarial samples. We can train our model with both the samples like clean data. Then we can generate lot of samples using FGSM, PGD, or maybe some other attack. And we can use both the samples to train our model. So now even if the attacker will generate a new samples using these attacks, uh, still our model will be able to detect that yes, this is a malicious or okay, whatever classification it could be, but our model will finally will able to detect it. We can add the noise, and we can go for gradient masking and adversarial example detection. We can also go for. So like you are seeing that okay, we can use these techniques and we can generate a lot of samples using these techniques, and we can include that in our training data. Noise injection, uh, gradient masking, and detection. So how you can like add noise? Random noise is added to input during training. So means now your model is trained on noisy data. So even if the attacker will change the data a little bit by performing adversarial examples, then our model will not misclassify that data. Make the model less responsive to subtle perturbations like yes, gradient masking, hide or alter gradient, so attackers cannot compute usable perturbations. Example, replaces gradient with zero gradient. So breaking FGSM style attack. The next is like adversarial example detection. System compares model output on clean versus perturbed version of the same input. So in that way, we can detect that we can prevent this kind of attacks. Now comes to the poisoning attack defense. So poisoning, we know that it was happening mainly at input level. So if we sanitize our data, then we can prevent this attack. Or statistical outlier detection, then cluster-based filtering, robust training methods, and trusted hardware and secure pipeline control. So by using this technique, we can prevent poison defense, poison attacks. So data sanitization and outline little bit in detail. Like data sanitization, the training data set is scanned for irregular, low quality or suspicious patterns before training begins. It removes corrupted input using filtering rules or pre-processing, reducing the chance of poison sample entering the model. Statistical outlier detection identifies unusual input by measuring a deviation from normal feature distribution. Poison samples often exhibits anonymous properties, making them detectable using statistical thresholds. So there are techniques which we can use to detect this kind of attacks. There are few different techniques like clustering based filtering. So we can do clustering. You know that by clustering, if you do the clustering, then different kind of samples will be in the same cluster, and by that way, we will come to know that these are the poison samples. Robust training method uses algorithm designed to reduce the influence of harmful or mislabeled sample during training, and enhances stability so that even if some data is poisoned, the model remains accurate and resilient. So then we can use some trusted hardware if it is available. Now comes to the model stealing defenses. So these are the four defense strategies by which we can prevent this kind of model. Limiting output information, adding noise to model output, API uses restrictions and rate limiting, model encryption, and secure deployment. Yeah. So coming to that limiting output information, instead of returning full probability vector, the model provides only the top one level or limited score. So it is not that it is giving the entire information to the attacker. Reduces the precision of feedback available to the attacker, making surrogate model reconstruction significantly harder. Adding noise to the predictions. Control noise is injected into model output before returning them to the user, or you can say the attacker here. So the attacker will not come to know the exact data. This disrupt the correlation. Attackers rely on to train a clone model while maintaining acceptable performance for legitimate users. Another attack is API attack defense strategy is API uses control and rate limiting. Restrict the number and frequency of queries. So we should implement this. Otherwise, what happens that the attacker is sending unlimited query, and so definitely at the end of the day he will come to know that okay, what this model is. And anonymous query patterns can be flagged or blocked to protect the model from automated stealing attack. The model encryption and secure deployment. So encrypted model file and running them inside secure execution environment protect against unauthorized access. So basically, this is about the unauthorized access. Attackers cannot extract internal weights or architecture even if they gain system level access because the data is here encrypted. Now comes to the privacy preserving machine learning. So these are basically four techniques. So how we can preserve of privacy. So differential privacy, which I explained you already. Federated learning, which yes, that's also explained. Another is secure multi-party communication and privacy preserving gains. So how this federated learning? You know that what is federated learning? Just I'm just revising that when you are training your model uh, locally, because like you can say there are hundreds of machines where you are training your model, and then you are sending their weights and then gradients, and then when finally the server Server is taking input from everyone and then training the model. So like how it helps local training. It means we are not, so what defense is giving, we are not, it is not sending the data. So prevent direct data leakage or data exploitation attack. Sharing only model update, like it is saying only, so mitigating model inversion attack. And again, aggregation aggregation is taking place on the server. So what defense is providing? It reduces membership attack, inference attack. No centralized data set. So if the data is scattered, then what is providing? It's eliminating single point of failure and large scale breaches. Even if the attacker is if it is attacking, then he may attack your local system, so he may not get the entire data. Defense, limit insider attack or database compromises. The limited observability of for attackers. It makes training data inference statistically difficult. Now, this is another attack, attack defense. This is called secure multi-party communication. So this is very interesting defense technique basically. So you know what? In our federated learning, there we were not sending our data. We were sending only gradients or maybe weights and those things. But here, what happens that multi parties are involved to generate or to train the model. Or so, for example, I would like to explain this with a small example. Like if you want to add 10 and 20, so we are never sending this 10, 20 to the model when we are trying to train the model. That time, what we can say that we will send that we are sending that like A is sending something. You could say that minus 50 or minus 30, and you can say, oh, some it some these two things. So the output will come minus 80. Then again, you will say to like B will say, okay, you add 50 and 60. So you will get 110. Then the final output will go from both the parties to the third party. And what the third party will do, now it is taking output from both these both A and B, and now it is adding. So you will see the final addition will be 30. So we are trying to add 20 and 10. So the final output is 30, and we got that. But no one knows that, okay, what type of data we are using here. That is basically the main thing of this thing. The computation is distributed across parties, ensuring no single party see the full input. So, and it uses cryptographic technique to protect data. So basically, this is not that cryptography. It's not encryption, decryption. Here, this cryptography basically a distribution of the data, which is the cryptography. Only the final result is revealed, while all inputs remain confidential. Now coming to the privacy preserving attacks. I'm sorry, privacy preserving GAN defense basically. So how this works? How synthetic data protects privacy? Train GAN on real data, generator or discriminator. You know that in the GAN we use generator and discriminator are trained using sensitive real data set, and a risk of memorization exists if training is not controlled. Then second is second step what we can do, apply privacy constraint. Use technical like DP, gradient clipping, and regularization. It limits influence of individual record during training. Learn data distribution. So GAN captures statistical pattern and correlation. It does not store or reproduce exact user sample. So now you know that we are having different data. We are not having yet actual data. Generate synthetic data. It produces new artificial samples with similar characteristics. and its synthetic data can be shared safely without revealing real user information. So we are not worried about here the real user information here. Defense against backdoor attacks. So you know that what backdoor attacks we were creating that small patch, and our model is behaving differently when it was getting the normal data, and when it was getting data with a small patch or small sticker on that. So we can, what we can, or how we can uh, prevent this kind of attacks. So basically, these are four strategies: input based inspection, and activation pattern analysis, neural cleanse and trigger reverse engineering, sorry, model pruning and fine tuning. Sorry. So we'll go one by one to each attack. So input based backdoor detection attempts to detect whether an input contains a suspicious triggered pattern. It uses pre-processing or anomaly detection to filter out input likely containing backdoor triggers. Then activation pattern analysis. The clean input and triggered input activation different neurons or activations clustered in hidden layer. By analyzing these internal activation, defender can spot abnormal patterns linked to backdoor behavior. Neural cleans and model pruning. So neural cleans attempt to reverse engineer the triggered by searching for a minimal pattern that causes misclassification. Backdoor classes requires much smaller perturbations, revealing the presence of a hidden trigger. A model training. Train the model normally. Measure importance of neurons and weights, low activation and small weight magnitude. It remove prune data, uh, uh, like low importance and neuron or weights. We can remove those. So in backdoor behavior is often stored in a small set of neurons, making pruning useful. So now, if you are even if you are removing a small portion of data, then it will not impact our model performance or like accuracy. Whatever. How to do fine tuning? So this is also a very important strategy. Identify dormant neurons. We are using a clean data set, and we find neurons that are rarely activated on clean input, but they are activated if they are rarely activated on clean input, it means they are suspicious. Backdoor neurons tends to stay inactive on clean data usually. Prone dormant neurons. Remove those low activation neurons. This break the backdoor pathway. Now again we can fine tune our model with this removed data. Advanced ML defense strategies. These are some advanced strategies, which is basically ensemble method, based neural network, randomized smoothing, and certified robustness technique. So what basically is this ensemble method? Ensemble learning combines prediction from multiple model trained independently. Because adversarial attacks typically target a specific model, Ensembles provides robustness by introducing diversity. For example, it can use bagging, boosting, or staking. What are the
Excuse me,
benefits
sir.
of this? Hello?
Excuse me.
Yeah, ma'am.
Sir, can you please wrap up at the earliest as we have another session aligned and the expert has joined?
Okay, ma'am, just give me maybe another maximum 5 minutes, not more than that.
Sure, sir.
Maximum 5 minutes. Okay. So what are the benefits of, like, we are reducing overfitting here, we are enhancing robustness, smooth our model errors, and harder for attacker to fool all model simultaneously. What is like Bayesian neural network? How it is protecting? There's a, like BNN provides uncertainty estimation, which is crucial for detecting adversarial or out of distribution input. Randomized and smoothing certificate robustness. So, like add noise to input during inference to create uh, a smooth classifier that is most stable under perturbations. We can use Gaussian noise to produce a more robust prediction that does not change easily with small adversarial changes. Certified robustness provides formal guarantees that a model prediction will not change within a specified perturbation range. Certifications build mathematically bound around model behavior to guarantee adversarial resistance. Then these are some key takeaway point, like AI models can leak or important information. Privacy attacks like inversion, membership inference, model stealing, and backdoor exploit model behavior. Once deployed, the model itself became an attack surface. No single defense is enough. So we have to provide multiple layers for defense. The technique like DP, backdoor detection, API control, encryption are essential for safe deployment. So how we can achieve trustworthy AI? We should have secure model plus responsible data handling. Thank you so much for paying attention. Questions, please.